This is chapter 1, basic device configuration. In this chapter, we are going to learn following sessions. 1.0, the basic information. This is the session I added to the Net Academy sessions. And our real session begins with 1.1, configure a switch with initial settings. 1.2, configure the switch ports. 1.3, secure the remote access. And then we have basic router configuration, verify directly connected networks. And the last session, which is almost same for all other chapters, that's the review session or a summary session, including a quiz. Without further ado, let's begin. 1.0, the basic. So here is the Cisco 2960 Catalyst switch. As you can see, this switch has many ports. Each port connects to a device. There are many ports connect to many devices at the same time. And these devices can communicate through this switch. The status for this switch is end of sale. It was first released in June 28, 2013. And in 2022 is the end of the sale. And then the support ends in 2027. So the Cisco refers to a switch's physical connectors as either the interface or port, with an interface type and the interface number. For example, this can be a Ethernet interface connects to Ethernet cable, interface number of this Cisco device. And it can also be a gigabit Ethernet port connects to a Ethernet port, Ethernet cable, or gigabit Ethernet cable, Cat5 cable, Cat6 cable. Just to summarize here, different type, different interface can support different maximum speed. So for Ethernet port can support up to 10 megabits per second. A recap, here we have a lowercase b, that means is a bit. So this is a 10 megabits per second. For uppercase B, that is a byte, where a byte equals to 8 bits. For fast Ethernet interface, you can support up to 100 megabits per second. For a gigabit Ethernet interface, you can support up to 1000 megabits per second. Like any other computer hardware, Cisco switches need some OS to run. This OS, the operating system, is a software, and the Cisco calls the OS the Inter-Network Operating System. Its acronym is IOS. And as you can see here in the picture, the box represents the Cisco device. In this case, it's the Cisco switch. And then it connects to the computer directly, physically through a cable, the console cable. And then it can also connect to additional computers through Telnet or SSH, where SSH means secure shell. It is a recommended way to connect your device remotely. It's more secure. The data being transferred between the devices is encrypted. This page shows 3 switches connect to computer differently using different medium, using different cables. So switch 1 connects to the computer 1 through a rollover cable. It's a RJ45 console cable called a rollover cable. And this requires your computer to have a serial port. Most computers don't have a serial port, but there's a solution. You can get a USB adapter. So that's in picture 2, the second figure. Switch 2 connects to computer 2, still using the rollover cable, but it also connects to a adapter. So one side of the cable connect to computer through USB port. The other side connects to the rollover cable. And then the third one is simply a USB cable. So switch 3 connect to the third computer, computer 3, through a USB console, and then the other side to the computer through USB port. This applies to modern switches. Now let's move to section 1.1. Configure a switch with initial settings. The switch boot sequence. After we turn on the switch, the Cisco switch, it goes through the following 5-step boot sequence. Step number 1, the switch loads the power on self-test, also called the post program. It is stored in ROM, where ROM stands for read-only memory. This memory is a volatile memory, which means it stores data as long as it receives electricity. In other words, it only stores information if it's on. Post check the CPU subsystem. It tests the CPU, DRAM, and the portion of the flash device that make up the flash file system. Next, the switch loads the bootloader software. This is the minimum software to run the system. The bootloader is a small program stored in the ROM, where ROM stands for read-only memory. This data is burned into the ROM by the manufacturer. The reason is burned, and most likely it cannot be erased, or of course it cannot be changed because the manufacturer doesn't want us to change it. It is the core system, also the minimum system, the software to run. This data is mainly the configuration data. That is run immediately after the post successfully completes. And followed by step 3, the bootloader performs a low-level CPU initialization. It initializes the CPU so the brain can start to work with other hardware devices, such as the memory, the hard disk. It initializes the CPU registers, which control where the physical memory is mapped, the quantity of memory, and the speed. Step 4, the bootloader initializes the flash file system on the system board. And then the last step, the bootloader locates and loads the default iOS operating system software image into the memory and give control to the switch over the iOS. So here, this picture, the boot system command is used to set a boot environment variable. And as you can see, the system is in the global configuration mode. Switch 1 followed by parentheses config indicates we are in the global configuration mode. And we enter this command called boot system. Where to boot system, we're going to get it from flash. And then followed by a series of directories. The folder contains the key file for the C2960 LAMBASK9 blah 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 dot binary file. We are going to apply the command to this binary file. The switch attempts to automatically boot by using information in the boot environment variable. If this variable is not set, the switch attempts to load and execute the first executable file it can find. The iOS operating system then initializes the interface using the Cisco iOS commands found in the startup configuration file. The startup configuration file is called config.txt, and it is located in the flash manner. In the example, the boot environment variable is set using the boot system global configuration mode command. Notice the iOS is located in a distinct folder, and the folder path is specified. Use the command called show boot to see what the current iOS boot file is set to. So here, the boot system is that command. Flash is the storage device. And then DC2960 is the folder, is the directory for storing the file we need to load. And then that file is called a C2960 RAM base K9. It's a binary file. It stores the iOS file. It's the iOS image file. We can even download it from the Cisco website. Now let's take a look at the switch, LED, and the light sequence. So here we have different LEDs on the panel, the front panel of the Cisco switch. The first light is called the system light, system LED. In short, it's called SysT. It shows whether the system is receiving power and functioning properly or not. Of course, if it's green, if it's on, that means it receives power. Otherwise, if it's off, that means no power supplied to it. And then the light below to it is the redundant power supply LED. We already know these devices, including switch, router, they need to be running continuously. And the power connect to it is crucial. Usually we need to connect the device to multiple power sources using several power supplies to keep it running. In case one power supply fail to provide the power, there is alternative a backup power supply. So this light indicates if the backup power supply is connected or receiving power correctly or not. So if the light is off, the RPS is off or not properly connected. If the light is green, the RPS is connected and is ready to provide the backup power. The port LED states, if it's off, no link or shutdown mode. If it's green, that means the link is present. And then if it's blinking green, the pattern is green, and then after a few seconds it's off, and then green and off. That means there's a data activity. The data is transmitting. Or if it's alternating green and amber, that means there is a link fault. If it's amber, the port is not sending data, common for the first 30 seconds of connectivity or activation. If it's blinking amber, the port is blocking to prevent a switch loop. We will talk about switch loop in later chapters. And there are other lights, such as the port duplex LED. In short, is the duplex. If the light is green, indicate the port is in duplex mode, which means it can receive and sending data simultaneously. Otherwise, it's not in the duplex mode. For the port speed LED, just called speed here, one is green, indicate the port speed mode is selected. The port speed can then be understood by the light associated with each port. Power over Ethernet LED for the PoE, present if the switch port is PoE, indicates the PoE status of the ports on the switch. The mode button on the lower right corner is used to move between the different modes, including the stat, duplex, speed, and the PoE. This table summarizes these lights and the meanings of the light patterns. The bootloader provides the access to the switch if the operating system cannot be used because of missing or damaging system file. The bootloader has a command line that provides access to the file stored in the flash memory. The bootloader can be associated through the console connection following these steps. Step number 1, connect to the PC by a console cable to the console port on the switch. Of course, the other side of the console cable connect to your computer. you're using your computer to control your switch through the cable directly. So configure terminal emulation software to connect the switch. And then unplug the switch power cord. Next step, reconnect the power cord to the switch. Within 15 seconds, press and hold down the mode button while the system LED is still flashing green. And step 4, continue pressing the mode button until the system LED turns briefly amber and then solid green. When it's green, that means it received data correctly. The bootloader switch prompt appears in the terminal emulation software on the PC. The bootloader command line supports commands to format the flash file system, reinstall the operating system software, and recover a lost or forgotten password. For example, the dir, the directory command, can be used to view a list of files within a specific directory. So here, this picture shows how you connect a computer to a switch through this console cable. And then this switch can also connect to other devices. To prepare a switch for a remote management access, the switch must be configured with an IP address and a subnet mask. To manage the switch from a remote network, the switch must be configured with a default gateway. Just to recap, default gateway is like a door of a room. In order for a person to enter into the room or coming out from the room, the person need a door. So the person need to exit this room and to explore the outside world or another room. Similar to the network here, in order for the data to go to other network, including the internet, there must be a gateway. So in this case, we need a gateway to be created. This is very similar to configure the IP address information on the host devices. In the figure, the switch virtual interface, SVI on the switch 1, should be assigned to an IP address. The SVI is a virtual interface, not the physical port on the switch. A console cable is used to connect to a PC, so the switch can be initially configured. So by default, the switch is configured to have its management controlled through VLAN number 1. Where VLAN 1 is the default VLAN, all switches have such VLAN. Where VLAN stands for virtual LAN, is virtual, and we can create many other virtual LANs. To think about VLAN just like a group of ports. We can create more groups and then put some ports to other groups or additional groups, mainly for security purpose and also for ease of managing these ports. We're going to spend more time on VLAN in the later chapters. For security purpose, it is considered a best practice to use VLAN 100 other than VLAN 1 for the management VLAN. Step 1, configure the management interface. From VLAN interface configuration mode, an IPv4 address and its subnet mask should be applied to the management SVI of the switch. Note, the SVI for VLAN 99 will not appear as up until the VLAN 99 is created and there is a device connected to the switch port associated with the VLAN 99. Note, the switch may need to be configured for IPv6. For example, before you can configure IPv6 addressing on a Cisco Catalyst 2960 running iOS version 15.0, you will need to enter the global configuration command SDM prefer dual-IPv4 -and -IPv6 default. and then reload the switch. Here is an example showing how to create a VLAN. And we are creating a sample VLAN called VLAN 99. First, we need to enter into the global configuration mode. You can see this by checking the switch 1 S1, followed by parentheses, and then config inside. This indicates we already enter into the global configuration mode. And then enter the key command VLAN, followed by a space, and then the VLAN number, VLAN 99. Hit enter key. Now we are in the VLAN configuration mode. We want to give a name of this VLAN, mainly for us to know what is this VLAN about. So enter the command name, followed by the name you want to give to it, such as management. And then if you follow the naming convention, we are okay here. Hit enter key to apply this command, and then exit. We'll go back to the previous configuration mode. And then we can also assign interface to the VLAN. Here, we're going to assign fast Ethernet port number 1 to the VLAN 99. We are in the global configuration mode. We enter interface and then followed by the interface name, fast Ethernet 0/1. And then now we enter into the global configuration mode. Here we use the switch port access followed by VLAN 99. We are assigning this port to VLAN 99 and hit enter to apply the change. Just to recap, for this particular switch, we only need the interface type and the 2 digits. So FA, that's fast Ethernet, and then the first digit 0 is slot 0, and then the 1 means port number 1. This table summarizes the commands associated with this topic. We use the figure terminal commands to enter into the global configuration mode. And then we use the interface VLAN 99 to enter into this VLAN. And then in the interface configuration mode, we enter IP address followed by the address and the subnet mask to assign IP and the subnet mask to this interface. And then we can also assign IPv6 address to it. And then use no shutdown to turn this on. Exit this configuration mode, we use end. This will return to the previous level, the privilege executable mode. And then we can also save the configuration by entering copy running config and then startup config command. So interface VLAN is management interface, therefore should be only one. Step 2, configure the default gateway. The switch should be configured with a default gateway. If it will be managed remotely, from network that are not directly connected to it. Because it will receive its default gateway information from a router advertisement message. And then the acronym RA, please remember RA, we will see this many times in the later chapters in this course. It's a RA message. It's a router advertisement message. The switch does not require an IPv6 default gateway. And then after we configure it, we can check the status of it. This command is pretty useful. It's the show command. There are several show commands. Includes the show IP interface or show IP interface brief command. Of course, there is an IPv6 version of this command available for use. So if you enter show IP interface brief, it summarizes the key information such as currently VLAN 99 is available, the IP address assigned to it, it is 172.17.99.11. Currently is in the shutdown mode, which means it's not on yet. To turn this on, we need to use the no shutdown command. And then if you want to see the IPv6 related information, of course, use show IPv6 interface brief command.